Hi students, in this video we're going to look at how to calculate binomial probabilities. Right, so after watching this video, the big thing we want to do to take away from this viewing video is how to use technology, and in particular the TI Inspire calculator to calculate binomial probabilities. Big things to remember is basically what is a binomial distribution and when can we use it. So binomial distributions can be used when we have a situation where all trials are independent. So we're doing multiple trials and they're all independent of each other. The outcome of one event doesn't affect the other. There can only needs to be two possible outcomes, so heads or tails, success or failure. And the probability of success needs to be constant for all of the trials. Remember we also how to use our notation. So BINP is our notation, where N is the number of trials and P is the probability of success, or what we want to see happening. When we're calculating probability, we don't just necessarily want all the values for a binomial distribution. We want to know what's the probability of a certain number of successes. So R, remember, is the certain number of successes we want to find the probability for. So R is number of successes, N is number of trials, P is probability of success. All right, when we're solving a binomial problem, the best way to consider it and how to solve the problem and work out what to do is to make a nice clear list of what are the values that we have and what are the things we need to calculate. So things like, do we need to calculate the probability of having 4 successes? That's how we'd write out that event, right? Probability of X, or a number of successes, well, R value here being 4. So in this case, my R value is 4. And then we might have an N value that we're told. Well, there might be 10 trials we're doing. We might be told the probability of success in our particular event is 0.4. Making a list of those variables can go a long way to solving these sorts of problems, because all of these problems we're generally going to solve using a graphics calculator, and it's good to know what those values are. So as we read the question, we want to make sure we can easily decode what those values are and where they fit in terms of our formulas and working out. Okay, so 2 functions on our calculator to use to start off with. If we want to find the probability in a binomial distribution of just one value of R, so let's say we're talking about flipping a coin 10 times and we want to just find the probability of there being 6 tailses. This would be a situation where we would use binomial PDF. Okay, binomial PDF, if we are looking for just one value of R. If we're looking for a range of values of R, so for example, if we want to find the probability of getting between 3 and 5 successes, as an example, or if we want to find the probability of X being greater than 5, or the probability of X being less than or equal to 4. If we have a range of R values we want to add up on some interval, this is where we'd use the binom CDF function. Okay, so in your binom PDF function, one R value if you've got multiple values on a range you want to just add up, say you want to have the probability of less than 5 successes or greater than 5 successes, you would use CDF. The only real difference is in your calculator for just one R value, you'll just put in NP then R, your one number of successes. For CDF, you'll be asked to put in your lower limit and your upper limit of successes. Now, the key thing to note here, students, when using this formula is we've got X is greater than or equal to, or less than and equal to. All of your expressions when we're using your graphics calculator, they all have to be written in terms of equal to or less than, or equal, in order to use your graphics calculator, they must all be written in terms of equal to or less than. And that's really important. Now, where to find these on the TI Inspire, you can just go to menu, then option 5 probabilities, option 5 distributions. and the PDF and CDF are the first options A and B in that list. So that's where you can find it. All right, so let's use them. So in laboratory trials, it was found that 89% of AA batteries lasted longer than 24 days in an Xbox Remote controller. A pack of 10 batteries were bought and tested, and our event X is the number of batteries that last longer than 24 days. All right, so reading this problem, a couple of things stand out. There's our p-value, 89%. So our probability of batteries lasting longer than 24 days, our probability of success is 0.89, and sneakily tucked away in the middle of this paragraph, my number of trials is 10. I bought a 10 pack of batteries, so there's 10 batteries I'll be able to trial and work out, apply this test to. Now, we want to determine the probability that 9 of these batteries will last longer than 24 days. Okay, so that means we're working out R equals 9. So we're working out the probability of X equaling 9, and using our graphics calculator, you can go menu, 5 for distributions, so 5 for probability, 5 for distributions, A for PDF this time. So binom PDF. And then on the Inspire, it will tell you to type your things in. It'll tell you to type in number of trials, probability of success, and then number of successes. So you just need to make sure you understand the question clearly and can point out those values. When you put all those things in, you'll get something that looks like this: 10, 0.89, and 9, and that will equal 0.38454. So the probability of success, or the probability that 9 out of the 10 batteries in the pack will last longer than 24 days, is 0.3854. Remember, 4 decimal places for probability, which is 38.54%. So pretty high. Now, determine the probability that less than 6 batteries last longer than 24 days. So that means R has to be less than 6. Now, the key thing to remember here is that when we are using our graphics calculators, we can't just use less thans. They have to be less than or equal to signs. So we'll need to do a little conversion here. The same way of saying R is less than 6 is saying R is equal to or less than 5. So R can be less than 5, R can be equal to 5, and that's the way we can use our graphics calculator, by using that less than or equals to notation, not the less than notation. All right, so in this case, we are also looking at a range of R values. As soon as we have an inequality, we're thinking a range of R values. So we are going to work out probability of X being equal to or less than 5 as binomial CDF this time. It's cumulative, we're adding things up. Once again, we've got 10 trials, my probability of success is 0.89. Now this time, well, because I'm using CDF, I need my range of values. Well, my lowest value is going to be 0. That's the fewest I can get. And my upper value is 5. When I put that into the calculator, 0.0025. So a very low probability that there's 5 or less batteries that last less than 24 days. All right, last one, determine the probability that 8 or more batteries last longer than 24 days. All right, so we want, in this case, R is equal to or greater than 8. That's fine. We've got an equal to or greater than sign. That means we can definitely use the binomial CDF function on our calculators again. We can use CDF here again because we're looking at a range of values, anything greater than 8. So we're going to use here binom CDF 10, 0.89. This time my lower limit is 8 because I want equal to or greater than 8. My upper limit is going to be 10, so I can have anywhere between 8 and 10 successes. Into the calculator, 0.9116. There's a 91.16% chance that I will get 8 or more batteries lasting more than 24 days. All right, so that's some of our binomial functions of our calculator. We've got a couple more, this time going in reverse. So this first one helps us work out R, the number of successes. So if we need to work out the number of successes, you'll use binom or inverse binomial. Once again, on your TI Inspire, this is going to be option C, and it will ask you to input the data where C is the probability we're looking for, where N is the number of trials you're having, where P is the probability. It will ask you for those things. Keynote with how this is worked out, students, is this is cumulative. So we are looking for a value where the sum up to this point is less than the probability we've been given. It is all cumulative. Now, if you need to know the number of trials that need to be taken to reach a certain probability, so if you know how many successes you want, but we don't know the number of trials, this time you use binom n. So the big giveaway, if you're calculating n, there's an n in the formula you've got there. And it will again ask for C, the probability that you've been given, P, the probability of success, and R, the number of successes that you want. Now, once again, students, remember this is all written as equal to or less than. So that is, again, really important. It has to be written as equal to or less than, and we've got to write our probability as less than C for it to work in our calculator. On your Inspire, so it's menu 5, and then inverse binom to find R is C. Inverse binom n to work out n, the number of trials, is D. All right, a quick example of that one. Andrew is currently making 42.3% of his free throw shots. That looks like a p-value for me, to me, 0.423. This season in basketball, determine the minimum number of shots he would need to make so that the probability he makes at least one 3-point shot is 85%. Okay, so we've been given a bit here. So we have to find the minimum number of shots he should take. That's an n value. We're asking how many shots does he need to take? How many trials does he need to have? So we need to find an n value immediately. We should be thinking, okay, I need to use inverse binom n to find my n value, not a probability. All right. Now we're told we want the probability of x, or we want r to be equal to or greater than 1. So my probability of x being equal to or greater than 1 needs to be greater than 0.85. Now, looking at how this formula is set out, it's all wrong. Okay, we can't have this written in this sort of form and use our calculator for it. We will need to change it. So another way of writing probability of x being equal to or greater than 1 is 1 minus the probability of x being equal to or less than 0. Right, we're using our complements there. So if I'm taking away all of the numbers that are 1 or bigger, also if I'm starting off with 100% and I want to just work out all the numbers that are 1 or bigger, I'll start off with 100% and just take away the probability of getting 0. So using our complements there. And what that does is it flips our sign around. Okay, it flips our sign around, which will let us use our calculator for this point. And that has to be greater than 0.85. Doing some rearranging there, negative p is less than 0 is greater than negative 0.15. Dividing by negative 1 switches my sign around. So x is less than 0 is now less than 0.15. Now I can start to use my function. So n is what I'm calculating, right? N, once again, Nspire, menu 5, D for this one, because we're finding n, binomial inverse, or inverse binomial n, and it will ask you to input all your values. Binom n, So it will ask you to put in your probability of, or the probability that you need to set as your limit, so 0.15. Your probability of success, 0.432 for each trial. And our R value, in this case of our formula, is 0. Put that into the calculator, and it gives you an answer of 4. So what that means is Andrew needs to take 4 shots to be 80, so that his probability of getting one of those shots in is 85%. Alright, so after watching this video, students, you should be able to use technology to calculate binomial probabilities.